Kubernetes and GKE Part 42. This episode has 20 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Explain horizontal pod autoscaler and when it may not work well. Here's a strong way to approach it. HPA scales pod replicas based on metrics such as CPU, memory, or custom metrics. It may not work well if requests are missing, metric server is unavailable, traffic spikes faster than pods can start, or the bottleneck is external such as a database. For queue-based systems, custom metrics like queue depth often work better than CPU. Nice. Let's continue. Question 2. Scenario. Pods are pending even though the cluster has free CPU. What could be wrong? Here's a strong way to approach it. Possible causes include insufficient memory, node selector mismatch, taints without tolerations, strict affinity rules, unavailable persistent volumes, pod quota limits, or topology spread constraints. CPU alone does not guarantee schedulability. Use kubectl describe pod to read scheduler events and identify the exact constraint. Great. Moving on. Question 3. What are taints and tolerations? Here's a strong way to approach it. Taints repel pods from nodes unless the pods have matching tolerations. They are useful for dedicated nodes, GPU nodes, system workloads, or isolating special environments. Tolerations allow scheduling but do not force it. Node affinity or node selectors are needed to attract pods to specific nodes. Alright, next question. Question 4. How do you secure Kubernetes secrets? Here's a strong way to approach it. Use least privilege RBAC, encrypt secrets at rest, restrict secret access by namespace and service account, and avoid storing secrets in plain Git. Prefer external secret managers such as Google Secret Manager with workload identity. Also rotate secrets, audit access, and avoid exposing secrets through environment dumps or logs. Let's keep going. Question 5. What is workload identity in GKE? Here's a strong way to approach it. Workload identity lets Kubernetes service accounts securely impersonate Google service accounts without long-lived JSON keys. It improves security by removing static credentials from pods. Access is controlled through IAM bindings between Kubernetes service accounts and Google service accounts. On to the next one. Question 6. Scenario. A GKE workload gets permission denied when accessing cloud storage. How do you debug it? Here's a strong way to approach it. Check the Kubernetes service account, Google service account annotation, IAM binding, and required IAM roles on the bucket or project. Confirm workload identity is enabled and the pod is using the expected service account. Then test token identity from inside the pod and verify no organization policy or VPC service controls rule is blocking access. Good. Here's another one. Question 7. How do you design a private GKE cluster? Here's a strong way to approach it. Use private nodes, restricted control plane access, Cloud NAT for outbound internet if needed, private Google access, least privilege service accounts, and authorized networks. Place workloads in controlled subnets with firewall rules, network policy, and workload identity. For production, include logging, monitoring, binary authorization, and upgrade strategy. Nice. Let's continue. Question 8. Scenario. GKE cost suddenly increased. What would you investigate? Here's a strong way to approach it. Check node pool scaling, workload requests, idle nodes, GPU usage, persistent disks, load balancers, logs volume, egress traffic, and newly deployed workloads. Compare billing by label, namespace, cluster, and service. Fixes may include right-sizing requests, using autoscaling, cleaning unused disks, reducing log noise, and applying resource quotas. Great. Moving on. Question 9. How do you make Terraform state secure? Here's a strong way to approach it. Store state remotely in a controlled backend such as GCS with versioning, encryption, and restricted IAM. Avoid putting secrets directly into Terraform variables or outputs because state can store sensitive values. Use state locking where supported. Separate state by environment or domain. and audit access regularly. Alright, next question. Question 10. What is Terraform drift and how do you handle it? Here's a strong way to approach it. Drift happens when real infrastructure changes outside Terraform and no longer matches the state or configuration. Detect it using Terraform plan, scheduled drift checks, or policy tooling. Handle it by importing intentional changes, reverting manual changes, or updating Terraform code after review. Let's keep going. Question 11. Scenario. Terraform apply wants to recreate a production database. What do you do? Here's a strong way to approach it. Stop immediately and inspect the plan to identify which attribute is forcing replacement. Check provider changes, module changes, state drift, lifecycle rules, and renamed resources. Use safer actions such as lifecycle prevent destroy, state moves, imports, or targeted changes only after review and backup validation. On to the next one. Question 12. Explain for each versus count in Terraform. Here's a strong way to approach it. Count creates multiple resources by numeric index, which can cause unwanted replacement when list order changes for each uses stable keys from a map or set, making it safer for named resources. In production modules, for each is often preferred for resources with meaningful identities. Good. Here's another one. Question 13. How do you structure Terraform modules for a platform team? Here's a strong way to approach it. Create reusable modules for common patterns such as VPCs, GKE clusters, IAM, service accounts, storage, and monitoring. Keep modules opinionated but configurable, with clear inputs, outputs, examples, versioning, and validation rules. Platform teams should also enforce policy checks and provide golden paths instead of unlimited flexibility. Nice. Let's continue. Question 14. Scenario. A Terraform plan passes locally but fails in CI. What could be the issue? Here's a strong way to approach it. Possible causes include different Terraform or provider versions, missing environment variables, different credentials, backend access problems, workspace mismatch, stale log files, or unavailable APIs, pin versions. Use consistent CI images, validate credentials, and run Terraform init upgrade only intentionally. CI should be the source of truth for approved applies. Great. Moving on. Question 15. How do you manage multiple environments in Terraform? Here's a strong way to approach it. Common approaches include separate directories, separate state files, workspaces, or a combination with environment-specific variable files. For production-grade systems, separate state per environment is usually safer and easier to control. Keep shared modules reusable while isolating blast radius between dev, staging, and prod. Alright, next question. Question 16. How do you use Python in DevOps or MLOps automation? Here's a strong way to approach it. Python is useful for building automation scripts, APIs, CI or CD helpers, cloud integrations, data validation, log analysis, and operational tooling. It has strong libraries for GCP, Kubernetes, Terraform wrappers, testing, and ML workflows. Good automation should include logging, retries, timeouts, error handling, tests, and clear configuration. Let's keep going. Question 17. Scenario. A Python automation script works manually but fails in a cron job. How do you debug it? Here's a strong way to approach it. Check environment variables, working directory, path, Python version, virtual environment, permissions, and credentials. Add structured logs and absolute paths. Cron jobs often fail because they run with a minimal environment compared to an interactive shell. On to the next one. Question 18. How do you handle retries in Python automation? Here's a strong way to approach it. Retry only transient failures such as network timeouts, rate limits, and temporary service errors. Use exponential backoff with jitter and a maximum retry limit to avoid overload. Do not blindly retry non-idempotent operations unless you have idempotency keys or safe duplicate handling. Good. Here's another one. Question 19. What is idempotency and why does it matter in automation? Here's a strong way to approach it. Idempotency means running the same operation multiple times produces the same final result without unintended side effects. It matters because automation can fail halfway and be retried. Terraform, Kubernetes reconciliation, and reliable deployment scripts all depend on idempotent behavior. Nice. Let's continue. Question 20. Scenario. Your Python script calling GCP APIs hits quota errors. What would you do? Here's a strong way to approach it. First, confirm the quota type, project, region, API, and request rate. Add exponential backoff, batching, caching, pagination, and concurrency limits. If usage is valid, request quota increases and add monitoring so the team sees quota pressure before failures. Great. Moving on. That wraps up this episode. Nice work practicing, and see you in the next one.